Well, so the objective is to actually first decode and understand what absolute value function is. Now, most of the times when you look at the types of questions that are assessed in DP are based on inequality. But before we go on to the inequalities and graphing, would first just understand the base of the or definition of the absolute value. Now, absolute value function is basically, let's say, is demonstrated or shown by two vertical bars, or referred also as like modulus function. So when I say absolute value is always basically absolute value for positive number will be the positive number itself. Absolute value for negative number also becomes positive. So when you talk about absolute value as name itself suggests that is taking the positive y value or positive value that you're inputting. So absolute value of x function when you talk about is actually irrespective of x being positive, negative, or zero. The output is always positive. So it's like, suppose it's like a machine, and that's absolute value x machine. If you input x value, either positive, negative, the answer is always going to be positive. So that's a simple meaning of the absolute value function. Now, for example, let's say I want to find out what will be the absolute value of pi squared minus 49. So phi squared, or let's say negative phi squared minus 49. So negative 5, let's say we're putting in the bracket. So it will become 25 minus 49. Now see this answer, first you subtract. So which will be, this will be negative 24. So absolute value of negative 24 is going to be 24 itself. So this is just a basic illustration on what absolute value actually is. Now, how do we define it? Now, when we simply take, now, as you can see that when absolute value of x, if I decode it in form of simpler term, it is x when x is positive, when x is positive, and equals to negative x when x is negative. Now, what does it mean is that, for example, I take x as positive 5. So absolute value of 5 is as it is 5. So when x is positive, you can see when I'm inputting x as positive, the answer is coming as 5 itself. But now if I'm inputting, let's say, negative 5 absolute value, it is becoming positive 5. So that positive 5, imagine if we didn't have this absolute value, the equivalent function that is there is basically you make negative number positive by multiplying by minus 1. So this answer again becomes, let's say, negative of negative 1, which is 5. So as per the definition, if you simply look at, if I draw a simple absolute value graph now, is basically, now suppose let's say I have y equals to x line, this is y equals to x line. So whatever is the positive value for the line, let's say this part you can see is the positive part. So this positive part remains positive. You can see that when x is positive, it is same. But what happens is that when x is negative, this is negative, this part actually has to become other way around. So this part basically becomes reflected in x-axis. And obviously this equation, when you see, is y equals to x, and this is y equals to minus x. And so the resulting absolute value function graph, basically what we get is this. So the absolute value function graph, according to the definition that we got to remember, is that for more than 0, it is y equals to x, and for less than 0, it is negative x. So this is a general definition of absolute value. Now, what logical or what I can say is that how do I explain it to you in different ways, that any part, suppose if you're talking about the graph, any part that is above x-axis remains as it is, but any part that is below x-axis gets reflected in x-axis. So for example, if I have to sketch the graph of absolute value of x plus 5. So what I'm going to do is I'm first going to draw the y equals to x plus 5 line. So let's say this is x plus 5, it will have a positive slope. I'll cut here y-axis at 5 and also x-axis at negative 5. So this coordinate that you see here is basically this is nothing but 0 comma 5, and this is negative 5 comma 0. Obviously, suppose what I'm going to do is first I'm sketching y equals to x plus 5 line. Now, as per the definition, whichever y values are positive, so y values whichever are positive, they remain as it is. So this part of the graph that you see here, this part of the graph is not going to change. So as it is, this part is going to be. Now, the part which is below x-axis gets reflected in x-axis. So this part of the graph that you see is down gets reflected in x-axis, and as a result of that, our total graph, when you draw the absolute value of x plus 2 graph, x plus 5 graph, actually is this. So this will cut here at negative 5. This side equation will be y equals to x plus 5, and this side it will be y equals to negative x negative 5, because it's a reflection x-axis. So if you just understand the basic thing is that you're making entire y values negative. So suppose this side, this was x plus 5, and if I multiply by negative in order to make these values positive, they become negative x negative 5. So this is the basic idea of how do we sketch the absolute value graph. Let us take one more example. Now, for example, let us say I have to sketch y equals to absolute value of 2x plus 7. Now, when I have to sketch y equals to absolute value of 2x plus 7, or let's say y equals to absolute value of 4 minus 3x, what you should just understand is that, let us say when you are sketching the graph, first you sketch the original lines like 2x plus 7. So 2x plus 7, when you sketch, it is cutting here at negative 7 over 2. Obviously, I'm sketching in my mind 2x plus 7 line, and here at 7. So this is cutting at 7. And if I draw the original line, it is going to be something like this. Now the absolute value of this line, absolute value of this entire stuff would be this part which is down, we cut down and reflect in x-axis. So this part of the line is y equals to 2x plus 7, which is original line itself. But this side is becoming negative 2x negative 7 because its entire thing becoming negative. So second stuff is, let's say when I'm doing this line here, so 4 minus 3x, y-intercept is at 4, and this is at 4 over 3. This will be cutting at 4 over 3. So when I draw the line, it is going to be something like here. And after that, you reflect the remaining part that you have in the x-axis. So this part, which is here, gets cut and gets reflected out here. So couple of things that you need to know is that, like, okay, how do I draw a graph of a single line? You should understand how to draw it. And if you don't know how to draw it, basically, there will be always a struggle when you're drawing the basic absolute value function. So this was about drawing the basic absolute value function. And now from here onwards, we'll take on how to solve the absolute value inequalities. So this part will basically cover the general idea about the absolute value equation and inequality. So when you talk about the absolute value equation, let's say for example, for what value of x is absolute value of x is 5. So obviously here we can see that if I take x is either positive 5 or x is negative 5, both is going to give me the answer as 5. So general solution for absolute value of x equals to a, you will get is x is plus or minus a. This is the general solution. So if I have, let's say, absolute value of x minus 5 is, let's say, 7, and I wanted to solve this equation. So in this case, what I'm going to do is, I'm going to do x minus 5 equals to plus or minus 7, because the net value, if it is plus 7 or minus 7, absolute value that is going to be 7. So that's the logic I'm using. So it will be x will be 5 plus or minus 7, which will be 5 plus 7 is 12, and 5 minus 7 is negative 2. So 12 or negative 2. So if I just want to check my answer, that are these values giving me the correct answer? So x is 12 here. So if I put 12 minus 5, that comes to be 7. And if I have negative 2 minus 5, which comes to be negative 7 absolute value, which comes to be 7 eventually. So both the answers that you see, they're fulfilling the equation. So this is the general idea or general logic by which you solve a particular absolute value equation. Now let us say my absolute value equation, sometimes it is like this: x plus 7 plus 3 equals to 0. Now here, when I solve, absolute value of x plus 7 is negative 3. Now you should use a common sense that how come absolute value of any number can be negative? So in this case, you just simply say no real solution. And how we can graphically show that. So if I look at absolute value of x plus 7, absolute value of x plus 7 is going to be something like this here. And if I draw y equals to minus 3 line, that's the second line here, they're not intersecting. So that's where you need to say that they will not have a general solution. What is really interesting is that when you are talking about the, let's say, absolute value equations, now blindly don't accept the fact that okay, I got this as an answer, so this is going to be verifying. Always you should go and check back whether the equation or inequality is getting fulfilled or not. Now in this part, what we'll talk about is how do we solve a quadratic inequality, I mean the absolute value inequality. So what will be important is that when you're solving a quadratic or absolute value inequality, like both are linked together. So let's say if I have, there are a couple of relations or there are a couple of things that you can understand or they're holding true. So there are 3 or 4 different ways in which you solve the absolute value inequalities. So first general method is by following the logic of it. So let's say when you have been given that you have to solve for what values of x is my absolute value greater than a. So when I look at that graphically, for me is going to be, suppose let's say this is the absolute value of x graph, and then I look at y equals to a line. Now y equals to a line is here. So now if I graphically try to find out the solution of this inequality, here is going to be that for what values is this absolute value of x graph is above a. So that is, if you notice, is this part and this part. And so if I solve for the intersection, so this equation is y equals to x and this equation is y equals to negative x. So if I draw y equals to x, obviously is one function, y equals to a, and if I solve for their intersection, they'll intersect it at x equals to a, which is obvious because when x is a, y is a. So this is a and this is negative a. So that intersection that you get is positive a and negative a. Now, when you're writing the final answer for any absolute value of x greater than a, then you can say x is greater than a or x is less than negative a. So this is going to be the general answer for this particular inequality. The second part is if I have absolute value of x less than a. So in that case, you can clearly see from your graph that that is happening only between these 2 values, which is, so absolute value of x is below a between, so the correct answer for this is going to be x between negative a and positive a. So these 2 are the benchmark formulae, you can say. You can use them to solve the inequalities of absolute value. Let us take a couple of IB style questions that have been assessed. So let us talk about, first part is, let us talk about this particular equation. Let's say 2x plus 3 is greater than 7. So for what x values is my absolute value 2x plus 3 greater than 7? So we're going to talk about this one. When it is more than a, any absolute value more than a, then it will be 2x plus 3 greater than 7, or second is, so absolute value of x is greater than, so x is greater than a or x is less than negative a, or 2x plus 3 is less than negative 7. Now you have to just solve these 2 inequalities to get the answer. So when I solve this one, I get x, 2x is greater than 4, it gives me x is greater than 2, or 2x is less than negative 10, which is x is less than negative 5. So these are the 2 answers. So x less greater than 2 or x less than negative 5. Let us take one where it is less than. So if I have got 2x plus 3 less than 7, absolute value 2x plus 3 less than 7, which means that this part, In that case, whatever is inside that absolute value, which is 2x plus 3, this must be between minus 7 and plus 7. And after this, what you just need to do is to solve this inequality. So when I solve this inequality, it is going to be negative 10 here. I'm going to just do minus 3 from each. This is going to be 4. And then divide each answer by 2. So it will be negative 5, x and positive 2. If my x is between negative 5 and positive 2, that is going to be the correct answer. Now, what will be interesting here is to actually visualize the solution graphically also. How can we solve this question graphically? So first thing what we got to do is we got to plot the graph of this function. You got to draw the graph of absolute value of, let's say, 2x plus 3. So absolute value of 2x plus 3 when I draw, first you draw y equals to 2x plus 3 lines. So this is going to cut at 0, 3. This is going to cut at negative 3 by 2. And this side, it is going to be something like here. So this equation that you've drawn, this side is 2x plus 3. And this side, that equation you've drawn is negative 2x, negative 3. Now, when you want to solve the inequality, you draw the second graph now as y equals to 7. So when I draw y equals to 7, that is this line, you got to find out these intersections. You got to find out what are these intersections now. So first we got to equate these. So 2x plus 3, if I equate to 7, I get 2x equals to 4. That gives me x is 2. Now why I'm equating this is basically solving the two simultaneous equations. So one of the equation is this, another equation is this. So you just need to solve for it and you get x is 2. Second intersection, let's find out, is basically if I have negative 2x, negative 3 equals to 7, I get negative 2x equals to negative 10, and that gives me x is, this is positive 10, and this gives me x is negative 5. So this point that you see is negative 5. Now let us see how graphically it makes sense that these answers are true. Now when I'm solving for, let's say, inequality greater than 7, where is this function above 7? So you'll see that it is above 7 here for sure, which is nothing but this, x higher than 2 or x less than minus 5. So this side, which is beyond this and beyond this. So that's going to be the answer for the first one. Second one, when I'm solving, is less than 7. So you need to see where is it below 7. So you can see that it is below 7 in this range, which is between negative 5 and positive 2. So that's the correct answer from the graphical perspective also. There's another way to solve this, and that is nothing but your quadratic inequality. So let us look at that as well. So when you're solving a quadratic inequality, now quadratic inequality, you need to first let us understand the basics of the that particular part also a little bit. So our objective at the end is to solve where is it less than greater than 7. Absolute value of 2x plus 3 greater than 7. Now, one of the rule that we need to remember is if absolute value of x is greater than a, then if I square both the sides, absolute value of x square when I greater than is also greater than a square, and absolute value of x square is going to be x square. The x square will be also greater than a square. So if you square both the sides, absolute value disappears, provided there is a single absolute value function. Now in this case, when I look at it is 2x plus 3 absolute value, the whole square greater than 7 square, if I square both the sides. So this, as a result, I get is 4x squared. This will become 2x plus 3, 2x plus 3 the whole square greater than 49. So now you open up the bracket. So it'll become 4x squared plus 12x plus 9 greater than 49. So this will be 4x squared plus 12x minus 40 greater than 0. And since coefficient of x squared is positive, you could just take 4 common, x squared plus 3x minus, let's say, 10 greater than 0. So we get x squared plus 3x minus 10 greater than 0, because if you divide by a positive number both the side, it doesn't change the inequality. So if you factor out this part now, it becomes x plus 5 and x minus 2 greater than 0. Put them on number line and draw the sign diagram. So negative 5 and positive 2. When I draw the sign diagram, obviously it's a happy phase graph. Coefficient x square is positive. Here it is going to be negative. Here it is going to be positive, and here it is going to be positive. You can see here it is positive above x-axis. Here it is positive above x-axis. It's a happy phase graph, so it'll be opening upwards. Hence, my correct answer that you get for this question is x greater than 2 or x less than negative 5. So this is the way you can solve quadratic inequality. I mean the absolute value inequalities in different possible ways.